What's happened, meteorology folks? Here are a few slides for you about 4 types of fog. Now, if you go looking for these slides later, they are part of the relative humidity and dew point slides. I've added fog to them so they're all in one place, but it's toward the end of the presentation if you're going back to look for these slides without watching the video. So here's the deal. 4 types of fog that we want you to know. The first one is called radiation fog. It's got another name, sometimes goes by ground fog, but folks, these are essentially clouds that are formed near the surface of the Earth, which is strange for us because we determined earlier this unit that clouds like to form in low pressure, which is up higher in the sky where it's cooler. So what would cause fog to start to form down near the ground? Okay, here we go. On a clear night, it's going to be relatively cool, most clear nights, which is going to allow for the temperature near the ground to cool off. Here's the key. This is by far the most important piece of fog formation for radiation fog. The air has moisture in it. There's water vapor. And near the ground where it's cold, that air touching the ground becomes cooler and cooler and cooler to the point where the relative humidity rises to 100%. The air becomes saturated because the temperature gets cooled off enough that the air can't hold any more moisture, right? At that point, with warmer air above it, because the ground is so cool, you get this type of condition for fog formation during late fall and winter. So right now, when we are in class, you'll probably see fog formation sometime this semester, right? And when there's a light breeze, not too strong of a wind, too strong of a wind will cause the air to churn into mix, and that's not great for fog formation or clouds in general. But with that light breeze, you get this type of fog forming, okay? This is a very common type of fog here in Kansas. As a matter of fact, most of the fog you've probably seen in this area out on the soccer fields or on the football field has probably been radiation fog or ground fog, okay? Now, second type of fog, advection fog. If you understand radiation fog or ground fog, then advection fog is pretty much the same thing. You have warm air, it's got moisture in it, and it moves over a colder surface. Now, this surface doesn't have to be solid ground. This can be a lake. This can be the ocean. This could be a bay, right? But that warm air is now over a cold surface, and so it starts to cool down, exactly like it does for radiation fog or ground fog, until that temperature gets down to the dew point, and the air is at 100% relative humidity. It's totally saturated, and that's when all of a sudden these droplets start to form that look like fog. Okay? It's basically a cloud. 100% relative humidity. Now here's the difference between advection fog and radiation fog. Advection fog involves the movement of air, and so that fog sometimes will continue to move and to flow. It's like a rolling fog, okay? Take a look at this picture here. This is a very dense, thick fog over a bridge. This would be very difficult to drive in, right? Which brings up the point of make sure that if you are going to be driving in fog-like conditions that you use your fog lights. Some of you didn't even know your car had fog lights. They're not bright and they're angled a little bit lower so that the light that hits the fog doesn't come reflective right back into your eyes and makes it really difficult to see. Okay? The third type of fog, my personal favorite, it's called upslope fog. This is like the other 2 types, except you don't have the moist air near the cold ground. That moisture in the air gets forced up the side of a slope, up a hill, up a mountain, up a canyon, right? And because it gets pushed up in elevation as it rides up the ground, it cools off. It starts to condense when the air becomes 100% saturated, right? 100% relative humidity. And that's at the dew point temperature. And so this fog starts to form. Take a look at the cloud here versus some of the upslope fog that's hugging right along the side of this mountain or coming down this canyon. Okay, upslope fog. Now the very last one is different than the other 3. This one stands alone. Okay, and here's why. We don't have warm air with moisture in it. As a matter of fact, we have cold air. But that cold air moves over a warm body of water. Here we have a swimming pool. Here we have a pond or a stream or a lake, right? The water's warm, so you need this. This normally happens in the summer times, early in the morning when someone wakes up. Maybe you're camping, maybe you're canoeing, and you look out and you see this fog. Here's what's happening. the water that is warm evaporates, turns to a gas and starts to rise. And the first thing that it runs into is this cold air that's over the warm water. And because the air is cold, it causes that moisture to cool off to 100% relative humidity and then begin to condense and form fog. Okay? This one is called evaporation fog or steam fog. Remember, this one's different because the air over the ground is not warm, it's actually colder. And the moisture comes from the body of water underneath it. All right? Those are the 4 types we'd like you to know. How will we test you over it? I will describe the formation of fog, and you will just have to decide which of the 4 types of fog it actually is. Radiation fog, advection fog, upslope fog, or evaporation fog. All right? Let me know if you have any questions.